Welcome to CS 1203 Database Systems 1, and this is Unit 3, Lecture Part 3. And in this lecture, we're going to talk a little bit about creating entity relationship diagrams. Now, one of the things I wanted to point out here is that we're actually going to be using a notation to document our entity relationship diagrams that is known as the crow's foot notation. I wanted to make you aware of the fact that this isn't the only notation. So you might come across things perhaps in textbooks you're reading, if you're out there searching in Wikipedia, etc., where you'll see a notation that may not look exactly the same as this. In fact, some notations look an awful lot like flowcharts, and they use, kind of rectangles and diamond shapes as part of the drawing notation that they use. So that's perfectly valid. There are multiple different notations to be used, and we're happening to use the crow's foot notation in this course because crow's foot notation is pretty popular and used quite extensively for creating entity relationship diagrams. So we're just going to jump right into looking at this. So, what is an entity? And, we've looked at and talked about the concept of a relation before. One of the things we talked about was this books relation that we had, and books lended, and library, and etc. Well, you can think of an entity as the same as a relation. So in this particular case, I have a entity that I'm calling books. And within that entity, I have a series of attributes. So, for example, one of the attributes is book ID, which in this case happens to also be our primary key. And we also have another attribute in here called title. So the way that we will typically create an entity object is that we're going to have the name of the entity, which typically is also going to be the name that we had given to the relation, and we're going to list all the attributes. We will often provide information about those attributes if we have it. So, for example, in this case, we know it's a primary key, so we should identify it as a primary key, and there's a variety of different notations that you can use for doing this. If you're using the DIA tool to create your entity relationship diagrams, it's going to automatically identify what is the primary key by making a selection and ensuring that that is then recorded or marked on the actual chart or diagram. Another thing that we'll often want to keep in here is the data type of the attribute. So basically all we need to have to build entities is to have the name, typically taken from a relation, and list the attributes, or at least the important attributes in that entity. And when I say important attributes, those are the things that would be related to how I define the primary key of this, things that are foreign keys, etc. So when I'm creating the relationships between different entities, it makes sense to the person that's looking at it. They can kind of understand how I'm creating that relationship, because oftentimes the way that that relationship is established is through the use of keys, be they foreign keys, primary keys, etc. So, moving on. Once I've defined my entities, I have to come out and start thinking about relations and the relationships that exist between them. So, if you think about these two entities that I have here, which is books and books lended, we know there's a relationship that exists between them, right? Books lended is going to tell us who that book has been in the past lended to, and perhaps who it's lended to now. Okay? The books relationship is going to tell us from the perspective of books lended what book has been lent out. Okay? So there's a relationship between these. And one of the things that we do to try to define that relationship is we draw a line, and the nomenclature or the way that we draw that line is an indication of what that relationship is. So one of the things you can look at this particular line that I've drawn and maybe make it a little bit more appropriate here is that it says I have a straight line here, and I have a crow's foot, as we call it, where the line splits out. And what this crow's foot is indicating is that we are going from something that is one item on this side and it's splitting out into many items on this side. So we call this a one-to-many relationship. Now, there's a whole different nomenclature around how we draw these symbols that has meaning. So the first thing I wanted to call your attention to is if the line is dashed, it's an optional thing. So when the line is dashed, it means that the object doesn't need to exist on this side. If you think back to the constraint that we talked about with referential integrity, you can see why this is important. If it's an optional relationship, then I don't have to have a constraint that tells me or that controls the referential integrity. So I don't have to worry about whether or not somebody removes a tuple on this side and the corresponding impact it might have on this side, if that relationship is optional. On the other hand, if the line is solid, it means that the relationship is mandatory. So when that relationship is mandatory, it means that I cannot have an item in here where there is not a corresponding item in this relation on this side, because that relationship is mandatory, and I would want to enforce this relationship with a constraint. So you can see how we have this way of identifying constraints through the relationship nomenclature that we put into the chart. Now, a few other of the symbols. If the crow's foot has a 0 in it, so for example, if my crow's foot kind of looks like this and then branches out, that has a specific meaning. It means that on this side of the relationship, I can have 0 items, 1 item, or many items. So this means 0, 1, or many. What that basically means is that I might have a book, and that book has not yet been lent out. Well, you can see the problem I have in these particular cases is that if I did this, it means that I could not actually create the book unless it was immediately lent out, because the relationship is mandatory, and this nomenclature, when I have the crow's foot that looks like this, indicates that I can only have 1 or more tuples or items, entities in this entity. So this is very important, this notation, because again, you can see the impact that it has on constraints. And the third variety of this doesn't have the bar going through it. It basically just has the crow's foot, which means many. That means that this relationship must have more than 1 for each item on this side. So you can see where this isn't as useful. This one we've got to be careful about its use, and this one is very, very flexible. There is also a notation on the side that does not have a crow's foot. Now, keep in mind, when I don't have the crow's foot, it means that I do not have many. I'm not breaking it out in some fashion, but there are some options that I can have on this side. So, for example, if I have a line, a straight line, or in many cases, a straight line with a single bar through it, that means that I must have 1 on this side. So, for any records that exist in the book lended, it means that I must have at least 1 book that corresponds to it. And that is what this means. Now, the most technically accurate way of doing this is to have the bar through it. Many times you'll see entity relationship diagrams where they don't put the bar through it, so whenever you see a straight line, we can assume 1. When I see a 0 and a bar, where the 0 intersects the line, like this, that means on this side of the equation, I can have either 0 records or 1 record. Again, that gives me some flexibility. So that means I could have 0 or 1 books, and this side says I have to have 1 or more books. Probably not a good relationship here. But that gives you a sense for what this notation means. And then the final one, which is when I have a line and 2 bars on it like this, that means that I can have one and only one relationship on this side. So when I have this symbol, it means one and only one. That means I cannot have zero, I must have one, and I can only have one. So hopefully that gives you a sense of what the relationships are like, and the notation that we use to describe them, and the role that it has in helping us to understand, by just looking at this diagram, the kinds of constraints, particularly referential integrity constraints, that I'm going to have to create for my database. Now we want to talk about a few special relationships. If you look at this particular relationship, we can identify this as having a many on one side and a many on the other. Now this is a very difficult relationship, and quite frankly, one that cannot exist in reality. If you kind of think back to the problem we have, is that I need to be able to uniquely identify a particular tuple, right? And when I have referential integrity, that means that I have to have a primary key on it that has to be unique. And one of the challenges I have from a referential integrity perspective is it basically this says many must exist when many exist over here. That means that I would have to simultaneously be able to create many here and many here. And that's not possible to do, because one or the other would always exist independent of the other one. So when we have a many-to-many like this, I can't actually have and implement this in such a way where it would meet the requirements of a referential integrity constraint, because referential integrity constraint says one must always exist here when one exists here. And this relationship does not allow me to do that. So, and just kind of throw some in here. Maybe this was books and borrowers. Now, this relationship cannot be implemented, and therefore is not valid in any scenario where I need to have referential integrity. So the way that I have to address that is I have to break this up into a tertiary relationship. So for example, what we tend to do here is we know the relationship between books and borrowers. Here is a many-to-many relationship. What I have to do is I have to break that many-to-many and create from it one-to-many types of relationships. And the way that I do that is by adding a tertiary relationship. And I might call this book borrowers. And essentially what happens in this case is that the book borrowers entity will adopt the primary keys from both the books entity as well as the borrower's entity. And as you can see, what it effectively does is it eliminates this many-to-many relationship by creating two one-to-many relationships. So when I have a one-to-many relationship, I now know that I can actually meet referential integrity constraints because of the fact that I have a one-to-many relationship, meaning that I can create the one and then the subsequent records that follow it. And then one other concept that I'm just going to address real briefly is the concept of a unary relationship. So if you think about a binary relationship, the idea is conveyed that you have two things involved. And in a unary relationship, the idea is that I only have one thing involved. And so let's look at an example of this. Let's think about the librarian relationship. Now, if you think about it, in the library, you probably have a lot of librarians, and those librarians probably have a supervisor who is also a librarian. So you might have a librarian and other librarians that report to that librarian. So that she's the head librarian or the supervisor librarian. That establishes a unary relationship. The subordinate librarians report to the supervisory librarian, which means there is a relationship that exists between them. And what happens is I need to be able to articulate this as a unary relationship. And in a unary relationship, essentially, I have my line that comes out and points right back at the same object. In this particular case, I have a one-to-many relationship. And in this particular case, it might be a little bit more applicable for me to have something that looks like this. So I didn't want to take too much time in this. Hopefully this has given you a good high-level understanding of some of the things that we need to do from an entity relationship diagram perspective, and some of the kinds of relationships that exist, and what the symbols mean and how you can use them, and of course how those symbols relate back to other elements that we've talked about, such as constraints. Because again, I can look at this diagram and understand some of the constraints that are required to implement it simply by looking at the relationships that exist.